Intro to book. Working in information technology, IT, is ever more complex but also significantly more competitive than ever before. This complexity and competitiveness are due to both technical innovations but also financial engineering. As someone who has been in IT for over 25 plus years, I have seen demand for IT skills such as Unix, Windows, Cisco networking, EMC storage, VMware, and even the holy grail of cloud computing become sporadic in demand. The competitive nature of commoditized IT has never been so challenging. I have seen entire IT departments decimated because of globalism, which is known in IT as outsourcing, offshoring and visa-based employment. These events have shown me that no matter how hard you work and how loyal you are, that your job is never what you expected. Whether you're a server administrator, pre-sales engineer, cloud developer or any other IT-focused role, you're likely seeing the job market changing aggressively. Part of this aggressive change is now requiring knowledge around DevOps and more specifically Kubernetes as well. Getting certified with Google Cloud shows you're more than knowledgeable about leading your organization in this area. This certification exam is also different from the other DevOps certifications due to the fact that Google was in fact at the forefront with DevOps and the creators of Kubernetes and for that matter SRE as we know it today. This book aims to not only address the exam objectives but also serve as a valuable, insightful guide to preparing for the DevOps engineer exam. This insightful guide aims to bring you step by step through the maze of required learning, from SRE to DevOps and then on to Google Cloud Services. Our journey will more than fully cover the knowledge base for the exam. My ultimate goal with this book is to provide you with a rapid learning experience that will enable you to pass the exam for the first time. By passing the Google Cloud Professional DevOps Engineer exam, you are providing yourself at the time of writing this book with a substantial difference in credentials than other co-workers, competitors and consultants. The exam is a year old at the time of writing and you, so hopefully passing the exam will be an advantage to you. I welcome you aboard this journey to becoming a highly sought-after Google Cloud Professional DevOps Engineer. Let's get going since we have a lot to cover. Chapter 1. What is a Google Cloud Professional DevOps Engineer? Chapter Introduction. In this chapter we cover the important facets of the Google Cloud Professional DevOps Engineer certification exam and dive into the exam objectives. This chapter will cover what this exam is about, why you should take the exam, and I'll provide my real-life working experience into what these objectives mean at a macro level before proceeding on to the micro-level details of each objective. Chapter Overview. In this chapter you will learn: what is the GCP Professional DevOps Engineer exam all about and why should you consider taking this exam? What are the exam objectives at a macro-level skill sets? What is the certification process and what should I expect before and after taking the exam? About the GCP Professional DevOps Engineer exam. Exam objectives. Note icon image Google Professional DevOps Engineer exam overview. Topic: why take the GCP Professional DevOps Engineer exam? In this topic, focus on what the exam is about and why you should take the exam. The main objectives you will learn about is: what is the exam about? Why should you take this challenging exam? What is a Google Cloud Professional DevOps Engineer? DevOps is an ever-in-demand skill set that companies and government entities are now clearly in need of. Passing the Google Cloud Professional DevOps Engineer exam will distinguish you as a leader in this constantly evolving area of development. Before discussing my insight into the exam guide, here is the official blurb from Google Cloud about what a professional cloud DevOps engineer is about. I'll follow up with my thoughts about the exam after the following. A professional cloud DevOps engineer is responsible for efficient development operations that can balance service reliability and delivery speed. They are skilled at using Google Cloud Platform to build software delivery pipelines, deploy and monitor services, and manage and learn from incidents. The DevOps engineer exam is not just about DevOps. It's about how Google looks at DevOps. What this means is that Google takes a very analytical approach to deploying applications. You will need to know the way Google incorporates site recovery engineering aspects. This, I can assure you, will challenge you on the exam if you have not read the Google SRE workbook. For example, prospective organizations that would benefit from the exam. From an organization perspective, I would also add that enterprise-focused organizations would also gain value from the certification. IT vendors, solutions integrators, enterprise development organizations, consulting organizations. Why should you take this challenging exam? I laid out 4 reasons to consider this exam over other industry DevOps and cloud certifications. The first reason is that the exam will validate your knowledge in not only DevOps, but also site recovery engineering, Kubernetes and Google Cloud services. DevOps and Kubernetes are ever-expanding areas when it comes to demand for certified professionals. Passing this exam will clearly demonstrate you have the knowledge. Google Cloud is an ever-expanding area as well, and having a Google Cloud certification can provide value to your career. This is especially true when a significant amount of your competition likely has Azure or Azure already. Azure and Azure certification holders' numbers are much greater than Google Cloud. Distinguishing yourself is very important nowadays, and obtaining a Google Cloud certification is one way to do this. The job market for IT professionals has been clearly documented to be shrinking, and the pool of qualified professionals is expanding. Obtaining this career-changing certification could very well be the difference between working or not working. Exam objectives. Exam objectives. Note icon image. Exam objectives covered. What are the tested objectives? In this topic we will cover the exam objectives and a brief review of each objective. The exam objectives are referred to by the Google Cloud as the exam guide. This exam guide is what you would want to review and study before taking the exam. Proper understanding of what you will be tested on as well as how you will be tested is a big deal in your success as a candidate for the exam. The main objective of this chapter: cover the exam objectives tested and provide high-level macro insight. Exam objectives: my unbiased review of the Google Cloud Professional DevOps Engineer exam. The exam objectives in the exam guide are clearly listed on the Google Cloud website. I have participated professionally in several areas of exam development and know more than a thing or two about test development stages. From an experience standpoint, I was a prior CompSci SME and Brocade SME who has participated in the development of 8 exams at various levels such as item development, job task analysis and cut score exercises. I can state that I believe overall the exam objectives are clear at a macro level and give potential test candidates a mid to high level of what to expect around objectives. However, I do not believe the exam objectives are at a micro level detailed enough for certification candidates, and therefore I have found this can cause students to get a bit overwhelmed. Having vague objectives can be misleading for the candidates and can cause the candidates to be studying wrong subject areas. Examples of well-written exam objectives are clearly defined in sections and in a logical order. View any of CompSci's exam objectives for what I am referring to. I will break down each of these tested objectives, skill sets, simply in a logical order and easy-to-digest format for an efficient test preparation process. The book has been written to provide significant detail from real working experience as part of the objectives coverage to enable efficient learning. My opinion of the Professional DevOps Engineer exam objectives, skill sets, is that they are vague since they do not drill down into what you need to prepare for. However, with some minor efforts it could be professionally specified without challenging the exam security and experience. Overall, I believe it's a great exam to obtain your DevOps expertise from. Let's now get into the preparations. Official exam objectives. As of the 22nd of February 2021, the exam objectives are referred to by Google Cloud as the exam guide. The objectives are broken into very clear sections with sub-objectives that are somewhat less clear in some cases. However, nothing in the objectives would be considered subjective once you understand Google's culture. For example, foster a learning culture is clear at a high level. But what exactly does that mean for exam purposes? We will dive into each of these objectives. For those that are not sure where the exam guide is located, the link is below. https://cloud.google.com/certification/guides/cloud-devops-engineer link. Exam guide section 1. Applying Site Reliability Engineering Principles to a Service. 1.1 Balance change, velocity, and reliability of the service. Discover SLAs, availability, latency, etc. Define slows and understand SLAs. Agree to the consequences of not meeting the error budget. Construct feedback loops to decide what to build next. Well, automation. 1.2 Manage service lifecycle, manage a service. For example, introduce a new service, deploy it, maintain and retire it. Plan for capacity. For example, quotas and limit management. 1.3 Ensure healthy communication and collaboration for operations. Prevent burnout. For example, set up automation processes to prevent burnout. Foster a learning culture. Foster a culture of blamelessness. Exam guide section 2. Building and implementing CI/CD pipelines for a service. 2.1 Design CI/CD pipelines. Immutable artifacts with container registry, artifact repositories with container registry, deployment strategies with Cloud Build and Spinnaker. Deployment of hybrid and multi-cloud environments with Infos, Spinnaker. Kubernetes artifact versioning strategy with Cloud Build and container registry, CI/CD pipeline triggers with cloud source repositories, Cloud Build GitHub app. Cloud Pub sub-testing a new version with Spinnaker configure deployment processes, for example, approval flows. 2.2 implement CI/CD pipelines, CI with Cloud Build, CD with Cloud Build, open source tooling, for example Jenkins, Spinnaker, GitLab. Concourse. Audit and tracing of deployments, for example, CSR, Cloud Build, Cloud Audit Logs. 2.3 manage configuration and secrets, secure storage methods, secret rotation and config changes. 2.4 manage infrastructure as code. Terraform Cloud Deployment Manager infrastructure code versioning, making infrastructure changes safer, immutable architecture. 2.5 deploy CI/CD tooling. Centralized tools versus multiple tools, single versus multi-tenant, security of CI/CD tooling. 2.6 manage different development environments, for example, staging, production, etc. Decide on the number of environments and their purpose. Create environments dynamically per feature branch with a GKE. Cloud Deployment Manager local development environment with Docker, Cloud Code, Scaffold. 2.7 secure the deployment pipeline. Vulnerability analysis with container registry, binary authorization. IAM policies per environment exam guide section 3, implementing service monitoring strategies. 3.1 manage application logs, collecting logs from Compute Engine and GKE using Stackdriver logging and Fluent. Collect third-party unstructured logs using Stackdriver logging and Fluent. Sending application logs directly to Stackdriver API using Stackdriver logging. 3.2 manage application metrics with Stackdriver monitoring, collecting metrics from Compute Engine. Collect GKE Kubernetes metrics. Use Metric Explorer for ad hoc metric analysis. 3.3 manage Stackdriver monitoring platform, creating a monitoring dashboard, filtering and sharing dashboards. Configure third-party alerts in Stackdriver monitoring, that is, PagerDuty, Slack, etc. Define alerting policies based on SLEs with Stackdriver monitoring. Automate alerting policy definition with Cloud DM or Terraform. Implementing slow monitoring and alerting with Stackdriver monitoring. Understand Stackdriver monitoring. Integrations, for example, Grafana, BigQuery. Using SIEM tools to analyze audit flow logs, for example, Splunk, Datadog. Design Stackdriver workspace strategy. 3.4 manage Stackdriver logging platform, enabling data access logs, for example, Cloud Audit Logs. Enabling VPC flow logs, viewing logs in GCP console using basic versus advanced logging filters. Implementing logs-based metrics. Understanding the logging exclusion versus logging export. Select the option for logging export. Implementing a project-level org-level export. View export logs in cloud storage and BigQuery. Sending logs to an external logging platform. 3.5 implement logging and monitoring access controls. Set up a CL to restrict access to audit logs with IAM and Stackdriver logging. Set a CL to restrict export configuration with IAM and Stackdriver logging. Set up a CL to allow metric writing for custom metrics with IAM and Stackdriver monitoring. Exam Guide Section 4. Optimizing service performance. 4.1 Identify service performance issues. Evaluate and understand user impact. Stackdriver service monitoring for App Engine and Istio. Utilize Stackdriver to identify cloud resource utilization. Utilize Stackdriver Trace Profiler to profile performance characteristics. Interpret service mesh telemetry. Troubleshooting issues with the image OS. Troubleshoot network issues, for example, VPC flow logs, firewall logs, latency. View network details. 4.2 Debug application code. Application instrumentation. Stackdriver debugger. Stackdriver logging. Stackdriver trace debugging. Distributed applications. App Engine local development server. Stackdriver error reporting. Stackdriver profiler. 4.3 Optimize resource utilization. Identify resource costs. Identify resource utilization levels. Develop a plan to optimize areas of greatest cost or lowest utilization. Manage preemptible VMs. Work with committed use discounts. TCO considerations. Consider network pricing. Exam Guide Section 5. Managing service incidents. 5.1 Coordinate roles and implement communication channels during a service incident. Define roles. Incident commander, communications lead, operations lead. Handle requests for impact assessment. Provide regular status updates, internal and external. Record major changes in incident state, when mitigated. When's all clear, etc. Establish communication channels, email, IK, Hangouts, Slack, phone, etc. Scaling response team and delegation. Avoid exhaustion, burnout. Rotate handover roles. Manage stakeholder relationships. 5.2 Investigate incident symptoms impacting users with Stackdriver RIME. Identify probable causes of service failure. Evaluate symptoms against probable causes. Rank probability of cause based on observed behavior. Perform an investigation to isolate the most likely actual cause. Identify alternatives to mitigate issues. 5.3 Mitigate incident impact on users. Roll back, release, drain, redirect traffic, turn off the experiment, add capacity. 5.4 Resolve issues. For example, Cloud Build, Jenkins, Code Change, Fix, Bug Verify, Fix. Declare the all clear. 5.5 Document issued in a post-mortem. Document root causes. Create and prioritize action items. Communicate post-mortem to stakeholders. Here you have the official objectives. Now let me cover each of these at a high level and provide some insight into each of the exam guide sections. High-level review of exam guide section objectives. The objectives listed above are the extent of detail provided by the certification body, which is by Google Cloud. What I'm going to now cover is each objective in a macro before we proceed to the next few chapters where the detailed objective coverage starts. Exam guide section 1. Applying site reliability engineering principles to a service. This section is really about how Google handles SRE and knowing how to communicate between your team members. With SRE specifically, it comes down to knowing how Google defines service level objectives. For example, overall, I think this section of the objectives are the least technical on the exam. Exam guide section 2, building and implementing CI/CD pipelines for a service. This section is mainly focused on what it suggests around CI/CD pipelines. This section focuses not only on CI/CD best practices but also on how to deploy a secure pipeline on Google Cloud. The section revolves around how to use Deployment Manager, Kubernetes Engine, Cloud Source Repositories, Cloud Build and Container Registry with some coverage with third-party DevOps tools. Exam guide section 3. Implementing service monitoring strategies. This section is really focused on Stackdriver capabilities and how to aggregate logs, alerts and use metrics to provide a highly available Google Cloud DevOps service. I believe this will be the hardest section for developers, for example, since this will likely be a higher learning curve for them. Exam guide section 4. Optimizing service performance. This section is all about Google Stackdriver, which at the time of writing is being rebranded to Google Operations. The exam at the time of writing is going to refer to Stackdriver. The section focuses on monitoring, logging and just about everything you can do with Stackdriver. Exam guide section 5. Managing service incidents. This section is focused on handling failures, outages and performance issues in accordance with best practices. As you may see, the Google Cloud Professional DevOps Engineer exam has a broad area around its tested objectives, skill sets. When preparing for any exam, it is of course critical to understand the objectives and how they will be tested. This book aims to make these objectives clearly defined for you, so all you need to do is learn them effectively. Let's get started now on the exam preparation. Chapter 2. Google Cloud DevOps Chapter Introduction. In this chapter we cover the important facets of the Google Cloud Professional DevOps Engineer Certification exam and dive into the exam objectives. This chapter will cover what this exam is about, why you should take the exam, and I'll provide my real-life working experience into what these objectives mean at a macro level before proceeding on to the micro-level details of each objective. Chapter Introduction. In this chapter, the coverage is specifically focused on ensuring the required baseline knowledge before proceeding to the objective coverage. We must ensure we have this baseline knowledge and comprehend important facets of DevOps before proceeding. This chapter will cover what the exam will be testing your round of knowing. Chapter Overview. In this chapter you will learn what is DevOps, what are pipelines, exam terminology, summary practice questions and answers, understanding DevOps. Exam objectives. Note icon image. Let's discuss DevOps topic. What is DevOps? This topic focuses on the essential basics of DevOps and covers how Google handles DevOps. The main objectives you will learn about is what is DevOps. DevOps overview. Simply put, technically, DevOps is an enterprise software development phrase that is used to describe an optimal agile relationship between development and IT operations. The main goal of DevOps is to change and improve the relationship of teams by advocating better communication and collaboration between these two or more business units. Effectively, removing silos and enhancing collaboration and understanding accidents can happen. Ensuring proper action can reduce mistakes and costs for the organization. DevOps is not only a technical shift in the way we run enterprise software deployments but also a cultural shift from the enterprise's old ways of running software releases, testing, updates and integrations, etc. Another common way to look at DevOps is that it is a software development lifecycle, SDLC, and its central goal is to provide a cultural change. Developers and non-developers work in an environment where the two departments may not be working together but instead against each other. Organizations that take improvement seriously won't tolerate this lack of collaboration and will invest in a DevOps strategy to effect change. In summary, what DevOps is all about. DevOps is a movement that enhances collaboration between development and operations, hence the name DevOps, and will remove the silos. Test tip: DevOps is about collaborating and removing silos, but also it's best to focus on speeding recovery rather than preventing accidents. Defining the pipeline. A pipeline, mainline, in the world of software development is a term used to effectively describe a workflow for your working copies in some vendor implementations. A workflow specifically has stages or phases, as they may also be referred to. The phase is when you advance to a stage moving towards the production deployment of software. Pipelines should ideally be designed for businesses that want to improve applications frequently and require a reliable, automated delivery process. Overview of how pipelines compare compared to the phases of the development lifecycle. Figure 2.1 shows how the build process in DevOps. Figure 2.1, DevOps build process. Image: we can see from the diagram above that the steps go from code to deploy. We will be discussing more in the upcoming parts of the book on how the DevOps processes fit into GCP services. Continuous integration, CI. Continuous integration, CIA, is the practice of merging all developer working copies to a shared pipeline several times a day. In practice, CI involves a centralized server that continually pulls in all new source code changes as developers commit them and builds the software application from scratch. Notifying the team of any failures in the process. A CI pipeline in its simplest form would be similar to this, whether it was deployed on premises or in the cloud. Benefits of continuous integration, CI. The main benefits of continuous integration are really focused on cost efficiency, reduction of risk and the removal of manual processes. Continuous delivery. Continuous delivery is the ability to facilitate changes of all types with developer copies, which includes new features, configuration changes, bug fixes and experiments into production, or into the hands of users, safely and quickly in a sustainable way. Continuous deployment can be thought of as an extension of continuous integration, aimed at minimizing lead time, the time elapsed between development writing one new line of code and this new code being used by live users in production. Benefits of continuous delivery. The main benefits of continuous delivery are focused on the lower risk of release, faster time to market and the high quality of software that is produced at lower costs. Continuous deployment can be thought of as an extension of continuous integration, effectively minimizing lead time, which is the time elapsed between development writing one new line of code and this new code being used by live users in production. Continuous deployment. Continuous deployment is just difficult and takes significant investment, of which only a few small and mid-size organizations can invest in. Benefits of continuous deployment. The main benefits of continuous deployment are lower risk, reduced lead time to market, quicker feedback and an improved return on investment, ROI. As well, with Google Cloud Platform, I generally like to highlight the workflow and describe why the code is kept in GitHub and how the pipeline works from start to finish. For example, when reviewing Google Cloud services, you want to get an idea of what DevOps services are supported and how they are supported. Figure 2.2 shows a simple CI pipeline using Google Cloud services from cloud source repositories to actual deployment of mainline containers on Google Kubernetes Engine. Figure 2.2, pipeline services in GCP. Image for Google Cloud Platform. The services that are used in the workflow above are listed below. Cloud Source Repositories is a GitHub that is hosted on GCP Cloud Build as a service that can be used to execute your builds. The container registry is used for artifact management and supports secure containers. Revision control and management. Kubernetes Engine is Google Cloud's hosted Docker container service, PAH. IAE Deployment Manager is an infrastructure as code solution that we can use to rapidly and consistently deploy cloud resources. Deployment Manager uses a configuration that describes all the resources you want for a single deployment. A configuration is a file written in YAML syntax that lists each of the resources you want to create and their respective resource properties. Deployment Manager bases its execution on config files, YAML, and templates, Jinja 2 or Python, and allows you to define your resources. Resources are represented in Cloud Deployment Manager by API resources. Deployment Manager is a GCP-only tool and as such allows you to access both beta and alpha features. We can preview this deployment by using the preview flag. Cloud Deployment Manager deployments create example config configuration file YAML, preview. Previewing a configuration allows you to see the resources that a deployment manager would create if deployed. Test tip. Preview flag should be used to verify resources before deploying. Deployment Manager will be covered much more in Section 2, more specifically around the exam objectives. Google Stackdriver, Operations. Stackdriver, Operations, is a hybrid monitoring, logging, and diagnostics for applications on cloud platform and DAOs. Test tip. Stackdriver was purchased by Google and was rebranded to Google Stackdriver. It has now been recently rebranded again to Operations. Stackdriver monitors the cloud service layers in a single SaaS solution. Stackdriver also has native integration with Google Cloud data tools such as BigQuery, Cloud PubSub, Cloud Storage, Cloud Data Lab, and out-of-the-box integration with all your other application components. In Figure 2.3 we see the main console of Stackdriver monitoring, operations. Figure 2.3, Stackdriver monitoring, operations. Image. Stackdriver has several features and components: monitoring, logging, error reporting, application performance management, APM, which includes trace, debugger and profiler. Stackdriver, operations, is covered in detail throughout Objectives Section 4. More on these Google Cloud services throughout the book. Google Kubernetes Engine, GKE. Kubernetes Engine is a cluster manager and orchestrator for running Docker containers. Kubernetes Engine schedules containers into a cluster and automatically manages them based on requirements you define declaratively using configuration files. In Figure 2.4 we see the main console of Kubernetes Engine with one cluster deployed. Figure 2.4, Kubernetes Engine. Image. GKE is built on an open-source Kubernetes system and integrates with other Google Cloud Platform services using dedicated client libraries for a variety of supported languages. Test tip. Binary authorization is the process of creating attestations on container images for the purpose of verifying that certain criteria are met before you can deploy the images to GKE. Kubernetes Engine clusters run on Compute Engine instances or virtual machines known as nodes. In this lab, you create a container cluster using the Cloud SDK and then use the kubectl command line tool to deploy and scale containers running your application on Kubernetes. Cloud Source Repositories. Google Cloud Source Repositories (CSR) is a single place for your team to store, manage, and track code. Cloud Source Repositories (CSR) allows developers to collaborate easily and more securely to manage your code on a fully featured, scalable, private Git repository. CSR can also be extended by connecting to other GCP tools, including Cloud Build, App Engine, Stackdriver, and Cloud PubSub. Cloud Source Repositories enables fast, indexed powerful code searches across all your owned repositories to save time. Figure 2.5 shows the output of using the list command to view repos after running the command Cloud Source Repos create developer. Figure 2.5, create a repository. Image. Cloud Source Repositories (CSR) allows us to mirror code from GitHub or Bitbucket repositories to get powerful code search, code browsing, and diagnostics capabilities. The following command allows us to mirror or clone a repository. Cloud Source Repos clone developer project equals my new project. Cloud Source Repositories allows developers to create up to 1,000 repositories per Google Cloud Platform project. Container Registry. Google Container Registry is a private container registry for managing Docker images. It provides a single place for teams to manage Docker images, perform vulnerability analysis, and decide who can access what with fine-grained access control. Existing CI/CD integrations allow teams to set up fully automated Docker pipelines to get fast feedback. Costs for use are based only on Google Cloud Platform storage and network usage. Test tip: the Docker push command will configure Cloud Build to store the image in Container Registry as part of the build flow. Container Registry vulnerability scanning automatically scans images when they are pushed to the registry for known security vulnerabilities and exposures. When new vulnerabilities are discovered, Container Registry checks to see if they affect images that are in your registry. Scanning is provided by the Container Scanning API and coverage is currently limited to Alpine, CentOS, Debian, Red Hat, and Ubuntu-based images. Cloud Build. Cloud Build is a continuous build, test, and deploy pipeline service offered by Google Cloud Platform. Cloud Build falls into the category of Cloud CI/CD continuous integration and continuous deployment. Test tip: the image field is used to configure Cloud Build to store the image in Container Registry. After a build completes, Cloud Build completely abstracts the build server away completely, saving time and accelerating development efforts. Figure 2.6 shows the build history of 4 build attempts. Figure 2.6, Cloud Build History. Image. Google Cloud Build can import source code from cloud source repositories CSR, GitHub and Bitbucket. CloudPool YAML and CloudPool JSON files are needed to build your Docker image using a build config file when using Google Cloud Build chapter wrap-up. We covered the main services that are covered in this exam. There are other services we will cover as well as cover the services in the chapter in detail in the objectives section. Chapter 2: Terminology to learn for the exam. The exam will test your knowledge around basic DevOps terminology. Terms that are essential to learning DevOps effectively are defined below. The list below summarizes terms briefly that would be tested in accordance with the exam objectives. Note that you may not be tested directly on these terms, but they are commonly referenced on Google exams and therefore knowing what they mean will clarify how to approach the correct solution or answer. Continuous integration, CI, is the practice of merging all developer working copies to a shared pipeline several times a day. Test all codes with the master code. Continuous delivery, CD, has the ability to facilitate changes of well types with developer working copies. This as a manual approval is generally required. Continuous deployment is an extension of continuous integration, CI, which aims to effectively minimize lead time through automation. This is the next logical step after continuous delivery where automation is implemented. DevOps is an enterprise software development phrase that is used to describe an optimal agile relationship between development and IT operations. Pipeline, mainline, in the world of software development is a term used to describe effectively a workflow for your working copies. Artifacts are container images, binaries, etc. that are stored in Container Registry or cloud storage. Triggers are used to sync up changes to the appropriate branch when changes are made to your code. Practice questions and answers before you begin. The main objective of these practice questions is to validate that you have learned the objectives of this chapter. 1. What is the term in DevOps that is commonly used to describe what is effectively a container workflow? Select 1. Process stream batch pipeline. 2. Google Cloud Build can import source code from which of the following sources? Select 3. Cloud source repositories CSR Cloud Bigtable Cloud Storage Bitbucket. GitHub Google Drive. 3. Which files are needed to build your Docker image using a build config file when using Google Cloud Build? Select 2. Dockerpool YAML build JSON CloudPool YAML CloudPool JSON Dockerpool JSON. 4. Which field is used to configure Cloud Build to store the image in Container Registry after a build is completed? Select 1. Cloud Build field Container field images field. 5. Which command will configure Cloud Build to store the image in Container Registry as part of the build flow? Select 1. Put update Docker push command. Push command. 6. Which preview flag in the cloud will validate that your Cloud Deployment Manager template is configured correctly? Select 1. Update, review, validate, preview. 7. What stores trusted metadata used in the authorization process? Select 1. Container Registry Cloud Build. Container Analysis Binary Authorization. 8. What capability automatically and digitally checks each component of your chain, Ensuring the quality and integrity of your software before an application is deployed to the production environment with GKE. Select 1. Container Analysis Binary Authorization GKE Security Scanner Master Network Authentication 9. Cloud Deployment Manager uses what 2 languages for their template files? Select 2. PHP Python Jinja 2 JavaScript 10. What does a resource represent in Cloud Deployment Manager? Select 1. Compute resources, network resources, API resources, cloud endpoint resources. Answers to section practice questions. The following are the answers to the questions. You may want to go back to the text and confirm you understand the answer before taking the exam. The exam questions are similar in format and difficulty. A process A, D, E, CSR, GitHub and Bitbucket C, D, Cloud Pool YAML and Cloud Pool JSON D, Images Field C, Docker Push Command D, Preview C, Container Analysis B, Binary Authorization B, C, Python and Jinja 2 C, API Resources. Chapter 3. SRE Fundamentals Chapter Introduction. This chapter will cover the fundamentals of Site Recovery Engineering, SRE. Site recovery engineering is a very significant part of the exam, and knowing how Google handles these tasks around fundamentals will be important for your success on the exam. We will cover the main fundamentals and terminology to understand in this chapter, and then as you proceed in the book the specific objectives will be covered in Chapter 5, Exam Objectives as well. Chapter Overview. In this chapter you will learn Understanding Site Recovery Engineering, SRE, terminology to know practice questions and answers. Understanding SRE. Exam Objectives. Note icon image. Let's discuss Site Recovery Engineering topic. What is Site Recovery Engineering, SRE? In this topic, the focus is on SRE fundamentals that will be covered as part of the exam preparation. The exam has a good amount of references to SRE, and knowing best practices and terminology is very important to your success on the exam. The main objectives you will learn about is what is SRE. Difference between DevOps and SRE. What are the common terms in SRE? Site Recovery Engineering Fundamentals. Chapter Note. Please be aware that this chapter contains only a sliver of knowledge around site recovery fundamentals, and that it is meant to provide just enough to give you what you need to get through the exam. For further study, I would recommend you review the Site Recovery Engineering Workbook, which is available free to read online or available paid in hard copy. Note that each objective that refers to SRE is covered in detail, and there is much more targeted discussion in Section 5 Exam Objectives. The history of site recovery engineering was documented back in 2003, when Benjamin Trina, he effectively coined SRE, was put in charge of running a production team consisting of 7 engineers. The purpose of this production team was to make sure that Google websites were available, reliable, and as serviceable as possible. Benjamin did this by giving the team the task of spending half their time on operations tasks so they could have a better understanding of software in production. Benjamin's team eventually became Google's present-day SRE team. SRE essentially involves creating a bridge between development and operations. SRE's approach to this is to apply a software engineering mindset to system administration topics. SRE is focused on shared ownership, meaning that neither the development nor the SRE team should have full ownership of components or resources. A site reliability engineer is essentially the perfect mix of a software developer and a traditional operations engineer. SRE should also revolve around reducing what is called toil. Toil is work that an SRE team member needs to deal with manually, such as through changes in code. There are other characteristics that toil could have, such as repetitive, reactive, or lacking enduring value. Reducing toil is done through automation. Toil is impossible to eliminate, but through a toil budget it can be managed. For example, Google expects that a toil budget would only expect 50% of each site reliability engineer's time goes to coding. The other 50% is for the feeding and daily care of existing applications. Toil can be measured through the following approaches. Identify what toil is for your organization. Select the unit to measure. Track the measurements to improve. Test tip. Toil should be recognized and then reduced by automation. SRE has a concept of error budgets that are aimed at measuring risk and should effectively balance availability, development, etc. With your team maintaining an error budget, this means that failure is accepted as normal and that requiring 100% availability is not necessary. However, with no unrealistic reliability targets set, your team has the flexibility to perform as needed. An SRE engineer needs to have a holistic understanding of the systems as well as the connections between the systems. SRE teams. An SRE team is responsible for availability, latency, performance, efficiency, change management, monitoring, emergency response, and capacity planning. Site reliability engineers create a bridge between development and operations by effectively applying a software engineering mindset to daily system administration tasks. SLA, Slow and SLE Service Level Indicator. SLE is a quantitative measurement the service provider uses for the measured goal. Metrics are collected based on these requirements and are based on the frequency of the probes. Examples: availability, latency, response time, throughput. SLEs should be specific and measurable as well. Service level objectives. SLOs specify a target level for the reliability of your service and are an effective tool to help determine what engineering work needs to be prioritized. It is a targeted value or could even be a range of values for a cloud service that is measured by an SLE using SLOs. Use the Keep It Simple Stupid (KISS) approach. Examples: cache hits per second, latency response under 60 milliseconds, or frequency of measurements 10 per hour. The Service Level Agreement (SLA) is a contract that the service provider promises customers on service availability, performance, or any other measures. These are effective promises made to the customer, and the customer is expecting performance around the SLA metrics. Example: 99.99% uptime or 2-hour response time. Test tip: terms to learn about SLO, SLE and SLA, as well as the relationship. It's important to note that the service provider bases the SLA, SLO, and SLE on assumptions, that is, the service will not be available 100%. Presented to the customer as an SLA that should be easily attained by the provider. Differences between SRE and Devops. Google's main viewpoint on what the differences are. Devops is all about the what needs to be done. SRE talks about how this can be done. I would recommend you take a few minutes to review a post by 2 Google employees around SRE versus Devops. Author Seth Vargo. Developer advocate and product manager Liz Fong Jones. Site reliability engineer https://cloud.google/products/gcp/sre-vs-develops-competing-standards-or-close-friends link. Top 5 pillars of DevOps, explaining what they mean for SRE. In summary, the top 5 pillars of DevOps for SRE are as follows. Reduce organizational silos, accept failure as normal, implement gradual change, leverage tools and automation, measure everything. SRE and DevOps are really 2 competing disciplines but also complementary disciplines when used effectively. Additional SRE topics. The following topics are in the exam objectives and will be covered in the objectives section of the book. Post-mortem and post-incident reviews are needed to review problems in production and effectively learn more about how your system works and can improve upon weaknesses. Feedback is also very important to receive and provide as an SRE. Feedback can be human or even tasking, such as metrics like latency, error rate, rework rate, and human time saved. SRE considers acceptable risk and error budget when error budgets are depleted. The focus should change from feature development to improving reliability. Exam objectives. Note icon image summary. Let's review what we learned. Topic: Site recovery engineering, SRE. On this topic, we reviewed what we covered in the SRE section. The main objectives to be summarized and reviewed. Site recovery engineering. A summary of chapter SRE is focused on shared ownership, meaning that neither the development nor the SRE team should have full ownership of components or resources. A site reliability engineer is essentially the perfect mix of a software developer and a traditional operations engineer. SRE has a fair number of terms to learn, such as SLE, SLO and SLO, as well as error budgets, toil and toil budgets. Service level indicator, SLE, is a quantitative measurement the service provider uses for the measured goal. Think of this as a metric that samples how you're doing. Service level objectives, SLOs, specify a target level for the reliability of your service and are an effective tool to help determine what engineering work needs to be prioritized. Think of an SLO as a simple target that is going to be referenced in how things get resolved. SLOs need to use the KISS method. The Service Level Agreement, SLA, is a contract that the service provider promises customers on service availability, performance, or any other measures. This target should be looser than the SLO, and because of that it is easier to accomplish. SRE and DevOps are really two competing disciplines but also complementary disciplines when used effectively. SRE terminology to know exam objectives. Notes icon image. Let's discuss site recovery engineering terminology topic. SRE terminology. On this topic, the focus is on terminology that you would expect to know for this exam. The main objectives you will learn about is site recovery engineering terminology for exam preparation. Site recovery engineering terminology to know for the exam. The exam will test your knowledge around a limited focus of SRE terminology. The list below summarizes terms briefly that commonly would likely be tested on the exam. Note that the exam will likely reference these terms but won't need to define them. For example, they will reference an SRE term such as service level objective with some form of action such as how would you recommend to your service provider customer how to meet the SLO. Post-mortem reviews, post-incident, are used to learn more about how your system works and can improve upon weaknesses. Service level agreement, SLA, is a contract that the service provider promises customers on service availability, performance or any other measures. The service level objective, SLO, specifies a target level for the reliability of your service. Service level indicator, SLI, is a quantitative measurement the service provider uses for the measured goal. TOIL is a work that tends to be manual, repetitive, automatable, tactical and devoid of long-term value to the organization. TOIL budget is a target used for TOIL measurement. The Google SRE book suggests spending no more than 50% of the time on TOIL. TOIL budget is 50%. Note that the list is far from exhaustive around SRE and is limited to only the scope of the chapter. SRE practice questions. Before you begin, the main objective of these practice questions is to validate that you have learned the objectives of this chapter. If you learn the chapter objectives, you will have mastered enough to pass the exam. Answers with explanations are on the following pages. 1. A site reliability engineer is essentially the perfect mix of what two roles in an enterprise. Select 2. Software developer, operations engineer, DevOps engineer, support engineer. 2. Which of the following is a contract that the service provider promises customers on service availability, performance or any other measures? Select 1. Service level indicator. Service level objectives, service level guarantee, service level agreement. 3. Which of the following tasks should be used to learn more about how your system works and can improve upon weaknesses? Select 1. Post-incident reviews, service level review, pre-mortem review, change reviews. 4. TOIL can be which of the following, except select 1. Repetitive, fully automated, reactive, manual. 5. TOIL is measured through what specific means? Select 1. Estimates tasking budget, self-service. 6. SRE quantifies acceptable risks such as an upgrade as an error budget. When your error budgets are depleted, does the focus shift from feature development to improving? Select 1. Response reliability, latency, uptime. 7. SLIs should be which of the following 2? Select 2. Specific, measurable, metered variable. 8. What type of component would be a user-created event that expects a response? Select 1. Request-driven pipeline, request invoked incident. 9. What is used to specify the target level for the reliability of your service and is an effective tool to help determine what engineering work needs to be prioritized? Select 1. SLO, SLA. SLI/TOIL TOIL can be measured through which of the following methods except select 1. Select the unit of measure, track the measures, identify what TOIL is for your organization. Dashboard management. Answers to section practice questions. The following are the answers to the questions. You may want to go back to the text and confirm you understand the answer before taking the exam. The exam questions are similar in format and difficulty. 1. A/B. Software developer, operations engineer. 2. D. Service level agreement. 3. A. Post incident reviews. 4. B. Fully automated. 5. B. Tasking. 6. B. Reliability. 7. C. D. Metered variable. 8. A. Request driven. 9. A. SLO. 10. D. Dashboard management. Chapter 4. Operations Suite, Stack Driver, Chapter Introduction. In this chapter, the coverage is specifically focused on ensuring the required baseline knowledge before proceeding to the objective coverage. We must ensure we know the important facets of Google Operations Stack Driver fundamentals for the exam. This exam does tests at a deep technical level around logging, monitoring, debugging, tracing and incident management with Stackdriver. Operations. Chapter Overview. In this chapter you will learn Stackdriver, operations, fundamentals, terminology to know, summary, practice questions and answers. Stackdriver, operations, fundamentals, exam objectives, notes, icon, image. Let's discuss Stackdriver topic. What is Stackdriver? Operations. This topic focuses on the most important aspects of understanding Stackdriver, operations, fundamentals. The main objectives you will learn about is Stackdriver, operations, overview. What is the operations suite? Operations suite, Stackdriver, is a hybrid monitoring, logging, and diagnostics for applications on cloud platform and DAWs. GCP purchased Stackdriver and was rebranded to Google Stackdriver. Stackdriver monitors the cloud service layers in a single SaaS solution. Stackdriver pulls performance metrics and metadata from multiple cloud accounts and allows users to view virtual and graphical representations of that data through custom dashboards, charts, and reports, which makes it easy for users to monitor, debug and fix issues. Stackdriver maintains native integration with Google Cloud Data Tools, BigQuery, Cloud PubSub, Cloud Storage, Cloud Data Lab, and out-of-the-box integration with all your other application components. In a nutshell, Operations Suite allows you to monitor, troubleshoot, and improve application performance in your Google Cloud environment. To access cloud operations, simply go to the Cloud Console and go to Operations. Operations, Stackdriver, monitoring. Main benefits. Fully integrated with Google Cloud Console, monitors multi-cloud, GCP and DAWs. Identify trends and prevent issues, lowers monitoring headaches, fix problems faster, aids with cloud security, aids with compliance. With Stackdriver from a monitoring perspective, defaults are intelligent and dynamic. Metrics retention is up to 24 months and writing metrics at up to 10-second granularity. There are also health checks that can be set up to monitor your cloud resources in specific regions. Important note for preparing for the exam for Stackdriver: the metrics are 1. Platform, system, application. Then we can 2. Ingest data metrics, events and metadata, so we can then 3. Be provided insight through dashboards, charts and alerts. In a nutshell, we select the platform, then we select metrics and then we choose how to monitor or view. Figure 4.1 shows the Stackdriver operations navigation side panel that lists the components in operations. Figure 4.1 Stackdriver operations. Image. The figure above is the Stackdriver option in the Cloud Console. Test tip: Stackdriver. You can write logs from Python applications using the Stackdriver logging handler. Workspace is a tool for monitoring resources contained in one or more GCP projects or ORs accounts. Each workspace can have between 1 and 100 monitored projects, including 1 or more GCP projects. You can have as many workspaces as you wish, but GCP projects and ORs accounts cannot be monitored by more than one workspace. Workspace contains custom dashboards, alerting policies, uptime checks, notification channels, and group definitions that you use with your monitored projects. Test tip: every workspace has a host project. Workspace can access metric data from its monitored projects, but the metric data and log entries remain in the individual projects. Figure 4.2 shows the Stackdriver monitoring dashboard that lists the dashboards that have been created. Figure 4.2 Stackdriver operations. Image. The above figure shows an App Engine dashboard and one for development. GKE having a very specific dashboard aids in the rapid identification of potential issues by providing an immediate visual through viewing graphs, charts. For example. Test tip: you can share Stackdriver charts by sending a parameterized URL. Figure 4.3 shows the Stackdriver operations dashboard that shows response codes, latency, events, incidents, etc. Figure 4.3 dashboard view. Image. The monitoring dashboard in the figure above is just a sample of what could be customized. It works simply by selecting the resource and then the available metrics you would like in your dashboard view. Metrics Explorer lets you build charts for any metrics collected by your project. Figure 4.4 shows the Metrics Explorer shows available resources and the metrics available for that resource. Figure 4.4 Metrics Explorer. Image. For example, with Compute Engine there are just some of the available options. Image. Uptime checks. Uptime checks verify 6 global locations. When you make a change to an uptime check, the delay could be 25 minutes. Figure 4.5 shows the uptime check that charts the latency between each region. Figure 4.5 latency uptime check. Image. Uptime checks are available under monitoring, and the dashboard will show you uptime, latency, alerts, checks passed, etc. Test tip: you can set up alerts via email and SMS. PagerDuty, web apps, webhooks, and even webhooks. Sometimes the agent may hang or the data stops collecting. You can invoke a restart of using the service by the following commands: sudo service stackdriver agent restart stackdriver logging. Logging supports these destinations for exported log entries. These exports are facilitated with the logging API, a cloud storage BigQuery pub sub-logging agent that you would like to install on a VM based on Fluent. Fluent is an open-source data collector, which lets you unify data collection and consumption for better use and understanding of data. Fluent is used to obtain or write log files to syslog and other supported log types. Install logging agent. Logging agent is installed the same way you would install the monitoring agent on a VM. It's just a different script that you're running. curl sso https://dl.google.com/add-logging-agent-repo.sh sudo bash add logging agent repo sudo apt get update log syncs. You need to create a logs sync, which includes a logs query and an export destination. To create a sync, use the cloud command cloud logging syncs. Create syncs can be set up at the Google Cloud project level, or at the organization or folder level using aggregated syncs. Figure 4.6 shows in the console how you can create a log sync. Figure 4.6 logging sync for GKE cluster using cloud storage. Image. Understanding sync permissions. To create or modify a sync, you must have the IAM role owner or logging logs configuration writer in the sync's parent resource. To view existing syncs, you must have the IAM role viewer or logging logs viewer in the sync's parent resource. Logs. Your GCP project has several logs that are relevant to the GKE cluster. This includes the admin activity log, the data access log, and the events log. Log info numbers to learn. Log entry size 256 kilobytes. Default log retention 30 to 400 days. Custom log retention 1 day to 3,650 days. Logging retention varies based on the type of log. The default ranges between 30 days and up to 400 days. Logs router checks each log entry against existing rules to determine which log entries to discard, which log entries to ingest into cloud logging, and which log entries to export using log syncs. List current logs. Cloud logging logs list. Table 4.1 shows the current options log type and how long Google maintains the logs for you. Table 4.1 log retention. Log type default retention time data access logs 30 days system event logs 400 days admin activity audit logs 400 days if you have illegal compliance issues with maintaining logs. You can configure Stackdriver for all projects and export logs to cloud storage. For more information on log retention, please refer to the Google Cloud documentation site here https://cloud.google.com/logging/quotas link. Figure 4.7 shows the resource types available in the display name. Figure 4.7 GKE resource types. Image. Default monitoring of your GKE clusters. Unlike other services in Google Cloud, GKE presents an additional choice of monitoring. Google Kubernetes Engine, GKE, has a native integration with cloud monitoring and cloud logging. When you create a GKE cluster, Kubernetes Engine monitoring is enabled by default and provides a monitoring dashboard specifically tailored for Kubernetes. With Kubernetes Engine monitoring, you can control whether cloud logging collects application logs. This monitoring can also be disabled for cloud monitoring and cloud logging as needed. Note: other options for monitoring. Many monitoring solutions use the Kubernetes daemon set structure to deploy an agent on every cluster node. Note that each tool has its own software for cluster monitoring. Heapster is another option that could also be used. Heapster is a bridge between a cluster and a storage designed to collect the cluster metrics. Cloud Operations is native to Google Cloud and therefore the recommended approach by Google Cloud. Stackdriver error reporting. Stackdriver error reporting analyzes and aggregates the errors in your cloud applications. We will notify you when new errors are detected. Error reporting brings you the process data directly to help you understand and fix the root causes faster. You can also receive email or mobile alerts via mobile applications. Figure 4.8 shows the reporting options for handling errors. Figure 4.8 viewing errors. Image errors that are grouped together are usually very similar, so error reporting keeps only 1000 samples. Keep all occurrences of an error, then exporting your logs to BigQuery will save all errors. You must know what the error codes 400/403 are in several contexts. Test tip: you must know what the error codes 400/403 are in several contexts. Operations Debugger. Debugger lets you inspect the state of an application at any code location without stopping or slowing it down. Debugger provides real-time capture by inspecting applications and does not have to stop the application. Supports runtime Java, Python, Go and using snapshots or log points. Figure 4.9 shows some of the options for selecting the source code to debug. Figure 4.9 Debug options. Image. Debugging captures the call stack and local variables of running application. You can also inject logging into a service without stopping it. Process to debug application. Clone project. Repository CD sample code. Cloud config set project. My dev 123 cloud app deploy version equals v1 cloud app browser validate output. Set up a snapshot rerun application. I will cover more target objective focused details on debugger during the objective coverage. Operations trace. Gather and analyze trace flows to understand performance issues such as latency and bottleneck discovery. Operations trace can also analyze apps and generate reports. Test tip: Trace SDK supports Java, Node.js, Ruby, and Go.